Hi everyone, good morning, good afternoon, wherever you are in the world. So, welcome to today's webinar. This is our second webinar. Name of the webinar is Navigating Regulatory Currents, Wind-Assisted Propulsion System and Maritime. I am Ash Lanal. I'm the Global Sales Manager at Oceanics. I'm thrilled to be your moderator today. So before we start the section, I would like to remind everyone that the section will be recorded and please feel free to ask your questions in the comment section. We will be answering them at the end of the section. So let's dive in and let's introduce each of the speakers to the stage. So first, I would like to introduce our speaker, Mr. Sandith Thandasherry. He's a founder and CEO of Navalt Group. He's having an experience of more than 20 years in the maritime industry. And I think he's not a person that I think I should explain more about. He's the core founder, he's a builder, and he's the pillar of Oceanics in Navalt. We would like to welcome you, sir.
Thank you.
Yeah. So moving on to our next speaker, he is probably everyone's favorite. That is Gavin Allwright. He is the Secretary General of International Windship Association. I'm sure you have seen Gavin everywhere in almost all the webinars related to windship, and I would like to call him the windman. He has contributed a lot to the wind propulsion solutions in the commercial shipping. He has a master degree in the sustainable development and specializing in the sustainable shipping. He also plays a vital role in a lot of regulations making process. Welcome, Gavin.
Thank you, Ashila. And Sandith is my favorite, so But thank you for your very kind words. I'm very, very pleased to be here.
Yeah, thank you. So next, our third speaker is Mr. Shahroz. He's the research and development lead at Bar Technologies. We all have heard about Bar Technologies, how they are the front of the wind propulsion systems, and he has learning in the adopting the AI in the maritime industry, and he's also a mechanical engineer, and he has brought up into the maritime industry. I think a lot of engineers are right now in the maritime industry, like me also. So I can relate to Shahroz Khan. So over the past decade, Mr. Khan has become one of the key figures in the energy efficient vessel design. Welcome, Shahroz Khan.
Thank you very much, Alicia.
Yeah. So next we have Mr. Makoto Yamaguchi. He is the executive fellow at MOL. So I think he's one of the key figures, one of the key speakers in our webinar today. We are so happy to have you on our webinar. I think he just jumped in the last minute and he didn't say any, "Oh, I can't do it," or any excuses. He was just driving in. I think thanks to Gavin for pulling him into the webinar. And as we know, like Makoto, he's had held a various leadership position in MOL, including overseeing the LNG ship projects, technical divisions, and the business development side. And we would like to hear more about you in your webinar section also. Welcome
Okay.
you.
Yeah, thank you very much, Ashina. I think very happy to be here to present the products to all. Thank you very much.
So next, and the last speaker of our section is Mr. Satyakumar Gaur. He is the environmental manager at Great Eastern in shipping, and he's a marine engineer with over 16 years of experience at sea, and more than 8 years he's been working ashore in the environment and energy domain. I think Satya sir is one of my first connections in maritime field. I think almost everybody in India knows about it. So welcome to the section, sir.
Thanks, Ashila. Thanks, Sandith, for giving us the opportunity. Thanks.
So let's move in fast. Let's quick. So first we'll be having the presentation, and I would like to invite Sandit sir to lay out the setting stage for the presentation. So over to you.
Yeah. Okay, let me, yeah. Okay, right. So, thank you, Ashila. So, my job is to let the stage be ready for understanding of wind propulsion before the experts come in. And I will talk from a perspective of performance analytics. That's the context I will try to set the stage here. So now the question, why would we need a wind propulsion or WAPS, is there are two things that are driving the whole process. One is from a regulation angle, which is driving the change, how to reduce the emission and the various targets set by IMO and various other government bodies and policy bodies, which is driving this wind solutions. The second angle is the fact that the fuel expense or the bunker price is the largest cost in the operating expense, which could be 50 to 70% depending on the vessel. So this is the second angle why we must look at wind propulsion. So these two things are driving more and more or increased adoption of wind technologies. Now, when we look at the emissions per se, and both the regulatory side as well as the cost side can be talked in terms of emissions of fuel consumption. So here, when we try to understand what is happening, one is from the various modes of operation, whether it's sailing or whether it's maneuvering or port operation. There is the whole lot of emission. And then based on the source, which is main engine, auxiliary engine, or boiler, and which we then break down into various sources of modes of emission, whether it is in the port or in auxiliary engine, or all the main engine emission due to weather effect or hull degradation, machinery, or what we say is a new ship condition. So if you do this segregation, then you can then understand what kind of decarbonization solution will work to reduce the whole emissions or fuel consumption. So that's, this layout is important to understand what we can play with. And if you lay down the whole decarbonization pathway in terms of all the solutions available, whether it's operation side or design side or various energy saving devices, the wind itself plays a big role in terms of a solution which will reduce the consumption of fuel, or we are shifting the energy need from entirely fossil fuel to partly wind solution, wind as an energy source. So in this, we will try to focus on propulsion as the prime driver need, because wind can also drive energy to auxiliary side by generating electricity like vertical turbine, etc. But the focus today is to talk of propulsion. And if you look at that way, the four major technologies, there are again few more of them. Like the four major technologies we would want to discuss today is like whether it's Flettner rotor, the suction wing, the rigid sail, and the kite. And this has dominated the installation in the past few years, and from the orders recently also, this seems to be the dominant four. Of course, there are soft sails and there are a few hybrid ones in addition to this, but this being the four, because if you see the installation across, so these are the list of, this is from Clarkson, and this shows a list of different kinds of ships and the technologies that are adopted. This include both what has already been installed and currently what we define as an order book, which is going to be installed in the next couple of years. So few things you can see is that historically Flettner rotors has been the dominant one, but based on the new orders, it is now suction sail that is becoming the dominant one. And mostly it is bulk carriers and cargo vessels, general cargo vessels, which are the really dominant one in the type of vessel. So this is just the context side. Now, when we talk of propulsion, when we try to understand the use of propulsion energy or reduction, when we do any analysis, we try to separate out the engine output, which is the shaft power, and the speed achieved. The reason why we do that is we try to separate out the engine performance from the hull side performance. So this is the first analysis side we try to do. And any energy saving device which is trying to reduce the propulsion energy requirement is analyzed in a particular way. There is this ISO 1930 for analyzing any energy saving device, which we usually do as a pre-post analysis. We do a speed losses and analysis. We try to understand what is the change in speed loss, hence what is the fuel saving, and then try to convert that percentage into fuel quantity, and then the using fuel price into the amount saved per year to finally understand the capex and the ROI per se. This is normally what we do for energy saving wise. But when we do in a wind, the analysis is slightly more complex, and which is one of the interesting things that I hope will come out of this seminar or this webinar. Now, typically energy saving device, when we do analysis, we try to avoid the rough weather condition, what we say is more than sea state 4, and try to do this pre-post analysis. Whereas when we have an energy saving device which is wind installed, wind works best when you have the wind itself is high, which is not necessarily sea state 4. So the optimum case where you might choose to go with an energy saving device like wind is different from a typical energy saving device. And the ROI computation also is different because you don't want to eliminate the high sea state or thereby the high wind condition when we do this analysis. So thereby the analysis is different. Now, when we do the analysis, another key point is when we do a cost of energy in a ship. So in a ship, you can say the energy comes from 5 sources. It could be, so of course, the main one is the engine and a fuel, some kind of fuel, fossil fuel, which can contribute to main propulsion or into the auxiliary. There are other sources which could be some battery tech, which is energy from the grid, or some fuel cell and some clean fuel, or it could be solar or wind. So these are practically the 5 types of energy. So when we do this analysis, the important point to remember is that wind solution, or at least most of them, need some energy input, which could be an electrical energy input. So there is the auxiliary power slight increase and there is a propulsion saving. The cost of energy of both are not the same. So for example, cost of auxiliary energy in terms of kilowatt hour is at least 15 to 20% more than the same cost of energy from a diesel engine mechanic when it used for propulsion. So this is a crucial element when we do this ROI and when we do this break-even. And this is something which we want to understand from the experts here. The second point to understand when we do analysis is most of the vessels, let's say, you may either start with no route optimization present and with no wind solution, which means you may go from a shortest route A to B, which is route 1. When we have route optimization installed and there is no WAPS technology or wind technology, you may follow a route 2, which is trying to identify favorable weather, avoiding the rough sea and reaching at the same time with a lower fuel consumption. Whereas when you have a scenario with wind solution and route optimization, you may have a different route 3, which is trying to get the benefit of wind, favorable winds, a different route and still having a lower fuel consumption. Keeping in mind that the energy input for running the wind propulsion is also more expensive than the propulsion gain. So this is something we must do when we are trying to do an ROI. So this is what I just want to set the stage for an analysis perspective. And I'm eager to listen from the experts about all these wind propulsion technologies. Thank you.
Thank you, Sandith sir. Thank you so much for laying this stage. It was wonderful to hear from you. So next we have Mr. Gavin, who will give you an update on the current adoption and the planned projects and discuss about the regulatory updates and more. So over to you, Gavin. Gavin, we're not able to hear you.
Gavin, you're on mute.
Yeah. Okay. Have you? Am I okay now?
Yeah, you are. Yeah.
Okay, and you can see my slides.
Yeah, we good.
Okay, lovely. So yeah, thank you, Sandith. That was a very comprehensive run through of the general aspects there. So just very quickly, I'm the Secretary General of the International Windship Association, and we're a network of actually now around 200 companies, academics, experts, etc., trying to facilitate the uptake of wind propulsion worldwide. Just a second. So we actually take an energy perspective, and I'm going to try and give you the overview of where we are and the push when we talk about regulation and the situation with the IMO, EU aspects, etc. So we take very much an energy application rather than a fuel application. So wind energy itself is across the board is zero rated for emissions. Obviously, it's zero rated for cost as well. We don't require the infrastructure. It's basically an energy source that's delivered to the point of use without any mining, refining, transport, bunkering, or storage costs involved. Of course, the wind propulsion the wind propulsion technology is a different matter. There's obviously going to be investment cost involved there. But actually, we could also be looking at a leasing approach or a pay-as-you-save approach to adopting these, which would move a lot of the heavy CapEx over to an OpEx aspect. So that takes some financial work, but with the adoption of a free energy source and retrofits around 5 to 20% of the propulsive energy being delivered, potentially optimized up to 30%, as Sandith mentioned, around weather routing as well, around the improvement or increase in size of the systems. And then we also have optimized new builds coming into the mix as well. So we have 4 vessels above 400 GT at the moment, operating at 50% plus on the wind. We have some other large vessels coming through over the next couple of years, and there we could be going up to even beyond 100%. But I'll let Makoto maybe talk a little bit about that with the MOL designs. I don't really need to go into the technologies here. I think Sandith has touched on the aspects of those, but I will talk about the market to a degree. But what we do need to remember here is when we're talking about wind propulsion technology, one of the misconceptions is that the wind is pushing the vessel. It's pushing the sail. Actually, that is an incorrect assumption. What it is doing is actually creating lift, very much like an aircraft wing creates a lift. So if you imagine an A380, one of those huge Airbus mega planes with tiny little wings, actually taking off, that's 800 tons going into the sky. Really, it's a little bit like a bumblebee. It really shouldn't be taking off, but it does because it generates a huge amount of lift. If you put that into a vertical situation, that's pretty much a wing sail. And you could be looking at, for example, the America's Cup, you'd be seeing boats going 3-4 times the speed of the wind. So if we were just pushing the ship, that would be impossible. Now, I'll just talk generally about ROIs because we have, there are a number of key considerations around the ROI from the cost side, but I'll talk about that in a moment. But we're also talking about 2 different aspects. We've got the wind assist, which is a retrofit, putting a system onto a ship that's not designed to take that system. So it's a ship designed as a motor vessel, and then you're putting wind on top. So you've got issues, for example, the amount of freeboard and the turbulence that creates around the wind, the sighting of the systems, the size that the system can be adopted. Does it need to be a retractable system? Can it be a full rigid system? Many, many considerations. So to create a general ROI for each technology and each ship is actually quite challenging. There are attempts, there are comparative attempts to do this, but they're always delivered with a large question mark over whether these are accurate or not. And really, the proof is the proof of the pudding is in the eating, is getting the systems on, simulating the systems. And then if we look at the primary wind, situation. Then we've got a lot of ability to really site the systems properly, have the largest systems with the best counterbalance measures on those. And we even move into the area of energy harvesting, where we're generating too much wind. So we can regenerate or capture some of that wind in other ways. I'll give you just a very quick overview of the market. Sandith's already shown some of the Clarkson aspects. One of the key problems, if you like, around innovation is we will see spurts of activity for each of the technologies, depending on the date they started, depending on a large order coming in, and then maybe a quiet period. So but each of these technologies is basically competing. Today, these figures here are from Q1 2024. Today, there are 47 ships installed with another 10 wind ready, meaning all of the work has been done on those ships. And we're looking at a pipeline around about this time next year being between 80 to 90 vessels installed. And that will be important when I talk about the next issue. Here are a few pieces of news that have been released. I won't go through them in detail, but we're starting to see small or medium-sized fleet orders. And this is indicating, rather than the one or two ships, this is starting to indicate that we're approaching a tipping point. We're approaching a point of inflection in the S-curve. So we have an S-curve in development, and I'll talk about that just in a moment with policy as well. That market potential, we're looking at, as I mentioned, 87 installations, wind ready, at the end of Q1 2025, maybe a little bit later, we're not sure. It's very difficult to tell with yard capacity, with the delivery of each vessel, but this is approximately where we are. So pretty much doubling every 12 months. That would lead, if we continue to do that, at 2030, that would lead to around about up to 10,000 installations, especially in the bulker and tanker sector, although we have the Ro-Ro, general cargo, etc. And then by 2050, the UK government has estimated that between 40 to 45% of the world fleet would be installed with some form of wind propulsion device. We think that is conservative. And indeed, we did an energy mix survey among ship owners, general maritime stakeholders, and policymakers. Actually, all of them, I think it was 87 respondents. This one's showing just the stakeholders from the maritime sector and 19 of the ship owners. What we did, though, which was different, we gave everybody 5 options they could choose for an energy source for 2030, and another 5 options for an energy source for 2050. But we included wind assist and primary wind into that mix. And this is never, as far as we know, has never really been done. And interestingly, the top 7 or 8 systems are always put in because they're seen as fuel or commoditized fuel sources. Whereas wind is often seen as an energy efficiency measure, which of course it isn't. It's a propulsion or a propulsive energy force. And the first 8 or 9 options actually match very, very closely to the responses that we've seen in many, many other surveys amongst the industry. But when wind was added, and this, that didn't change, but wind came very strongly into the mix too. So, of course, retrofit and wind assist was seen as a strong option for 2030, but then primary wind was seen as a strong option for 2050 especially. And if we put them both together, it became, by 2050, actually if you like, the energy of choice, or it would be certainly the energy used in association with others. Now, this slide just shows very quickly the policy framework. So we've got a large number of policies coming through from IMO, which are all in the blue. We also have the EU policies coming through, which are in the green, and we have industry aspects as well coming through in the pink. Now, the issue here is none of these singularly do the job. Not one of these drivers will actually, or one of these levers will actually push wind propulsion to being a serious contender. However, collectively, the pressure being exerted on the industry is going to be almost irresistible to adopt a solution that is globally available today. It's very low cost. It's zero cost as an energy source. But of course, the issue will be around how much does that cost to get it onto your ship. And I'm going to focus just on Fuel EU Maritime in a moment, because that's the one that's pending, and actually quite an important one. But the dashed pink line that goes through the middle is the estimates that I showed you in the previous slide from the EU and from the UK government. And you can see the inflection point, that steep upward slide around about the end of 2025, 2026. This is when most of the policies are either in place, so the Fuel EU Maritime, EU ETS, EEDI, CII, etc., but also other of the IMO GHG reduction measures, for example, a GFI or a GFS, and the carbon pricing won't be in place, but it will be decided and indicated for implementation in 2027. So at that point, we should know exactly what we're facing in the pipeline. Plus CII will be under review at that point as well. So just very quickly on Fuel EU Maritime, there is, many of you will already know this, but some of you maybe don't, that there is a wind reward factor within the Fuel EU Maritime regulation. Now, what this does is you have the standard formula to calculate the carbon intensity of the vessel and the fuel that is being used, or the energy that is being used. Now, wind couldn't be included in that formula this time because we didn't have a standardized approach for calculating it. We had lots of different approaches, but there wasn't a standardized one. And we've been working on that. And actually, I'll show you that we have a submission that's going into IMO just at the moment. But what this does, it recognizes that wind is a very special energy source, that it's actually zero emissions across the board, not just in GHG. And you're given a reward factor for it's between 1% and 5%. So this can actually make you compliant through the 2025-2030 period, and actually substantially contribute, especially if you've got the 5%, to the 14% that's required for 2035. I notice I've only got a couple of minutes, so I'm going to move through very quickly on the last ones. We have the GFI submission into IMO just at present for MEPC 82. And MEPC 81, we had our wind propulsion white paper submitted. So if you're interested in a lot of the safety or technical issues, a lot of that is covered within that white paper as well. And there are links to the EMSA report on technical issues as well. But pretty much those issues are not huge issues now. It's much more about the facilitation. I'm going to skip this one because it's a bit of a general one. This will be my last slide. So what other aspects can we actually look at here? Well, we could be offering tax credits for wind propulsion. The wind routing and wind corridors, incorporating wind into green corridors. We've always had wind corridors. They're called the trade winds. They're called the monsoon winds. But we don't use them anymore. We actually see them as a problem rather than a solution for fuel-powered vessels. When we incorporate wind, we actually have conveyor belts of energy that we need to be focusing on. An equitable transition. this is really important, that we really need to be promoting low-cost energy sources and financing those for least developed countries and small island developing states. I've already mentioned leasing, wind ready, actually having a standard where every vessel that goes into a shipyard for its dry dock or new vessels that are being built, we could actually make them all at a reasonably low level wind ready. So strengthening the hull areas where wind propulsion would be taken on board, making sure, or in the designs, looking at radar blanks, navigation issues, and at a very, very low cost at that time. Doing it later is a higher cost. And just one last one I'll mention is, we're talking about carbon pricing, having an ambitious carbon pricing structure, but making sure that finance comes back into the industry to actually fund the systems that are being developed. This will turbocharge the entire decarbonization of shipping, and we really need to be mindful that this should be the way to go. And I'd just like to say thank you very much. As we like to call this, is a win-win-win situation, but we're looking to rewind, not rewind to the past. So if nothing else you take from my presentation, please remember those two expressions. And I'm really looking forward to the rest of the presentations. Thank you.
Thank you so much. I think while we were talking with Gavin at the initial stage, he mentioned that he could go for days talking on the same topic. I think.
My apologies.
Yeah. And no, it's okay. We love hearing you. So thank you for your valuable insights. It was great. And next we have Mr. Shahroz to talk about his perspectives on the bar technologies as a technology provider, and he will be discussing about the challenges and opportunities they face. Over to you.
Let me start sharing. First of all, can you see my screen and can you hear me loud and clear?
Yes, speaker.
Okay, thank you very much, Alicia, and thank you very much, both Sandith. I fully agree with you that there are certain aspects, especially from route optimization point of view, if you want some great ROI. And thank you very much, Gavin. Like as always, like it's always nice hearing you, and definitely it was a very nice holistic view on wind-assisted propulsion systems. So let me start with, for those who are not aware what BAR Technologies is. So BAR Technologies, founded in 2007 after their involvement in America's Cup. It's a maritime innovation simulation-driven company with an ultimate aim is to use its unique design philosophy to build state-of-the-art approaches and technologies to decarbonize maritime industry. So BAR Technologies has pioneered various technologies to reduce emissions in the maritime sector, and among which is Windwings, which is a very unique wind-assisted propulsion system. It is a rigid sail, and it can be fitted to an existing vessel or to a new build, and can provide on average 1.5 tons of fuel saving per wing per day, and can goes up to 6 tons even in good condition. So for example, if the vessel that you're seeing here is fitted with 4 wings, so you can times that for 4 times 0.5 tons of fuel savings per day. And these staggering savings were only possible with a very unique design. So the wing has a aerodynamic span of 37.5 meters. So it's a very tall structure, and it's composed of 3 elements. So the first is the leading element, which is of 5-meter width, and the second is the main element, is a 10-meter width, and the last one is the trailing element, which is 5 meters. So in total, it provides 20 meters of chord length that brings up to a surface area of 750 meter squares. An interesting factor is that like this surface area is is same as the surface area of 747 jumbo jet, like 3 turbojet wings. And this unique design provide us 2.5 times more thrust compared to a single wing. And the entire structure is made of steel and industrial composite material. It is fully autonomous. It can adjust itself to obtain maximum savings to various wind conditions. Talking about a bit of savings, so our simulations have showed us, as I said, like on average saving on global routes, we can achieve 1.6 tons of say fuel savings, which equates to 5.12 tons of CO2 emissions. And if we have good conditions, and the conditions that we call, like if the wind is around 20 knots and the true wind angle is around 100 to 130, we can even achieve to staggering 6 tons of fuel saving per wing per day, and that can equate to 19.2 tons of CO2 reduction. Like these huge numbers can only be possible through the unique design and the unique system that helps to propel this structure. And our simulations have also shows us, for example, if for a cargo vessel or a bulk carrier going from Brazil to China, in a full load condition can give you a saving of 1.7, and on the ballast condition it can give you 1.3 tons of fuel savings per wing per day. And for example, if the vessel is going from Japan to Canada, it can go towards 2.6 tons of fuel saving, and on its way back in the ballast condition it can give you around 2 tons of savings. So this definitely shows what Sandith commented on, like we definitely need some nice routing optimization, and also like the Wind-Assisted Propulsion System is also made for specific routes. For example, you can see like for various routes we can achieve good savings for some routes with small and some slightly bigger savings. So far, Gaur Technologies has fitted 6 wings on 2 different vessels in the third quarter of 2023. So the first one is Pyxis Ocean, and the second one is Bergeborg carrier Berge Olympus from Bergeborg. And now we are in a very interesting time that recently Gaur got a contract from Maritime to fit our technology wind wings on their 34 new build vessels, as Gavin mentioned in his presentation. Regarding the operational mode, the wind wing system has various operation modes to achieve maximum efficiency in various wind conditions, and also to provide safe and agronomic operations. So among which is there are 3 main operation modes. One is the active mode, when the wind is producing the maximum efficiency or providing you maximum fuel savings and maximum CO2 reductions. And the other 2 are active and passive feathers. And these 2 operations are mostly when we don't need the lift, and when there are scenarios that wind is above the operational limit, or if there's any failure scenarios and or vessel blackout scenarios. So the entire system is automated, it identifies itself, it operates itself, and with very little input from the human. So these are some operation modes in action. Here you can see like the port operation mode and the folded at sea, and when it's like at the active feathered mode. Moving further, these are some slight segment of the results of our first vessel, Ocean Pyxis, which was fitted on with 2 wings. And here you can see here the green area represents, this is an on and off wing test. So the green area is the area where we have when the wing was on, and the red is when the wing was off, when the wing was down. And the yellow is that transitional area. So here you can clearly see that when the vessel at the constant RPM, you can see like as we have put the wind wing off, you can see the reduction in the speed, and the speed is higher compared to when the wing is off. And similarly, you can see also in the increase in the engine power, how the engine power has increased when the wings were off. So that definitely shows some promising results. And all these results were further validated over the 6-month voyage of this Ocean Pyxis vessel. And then we validated that this vessel over 6 months in favorable conditions achieved 32% of fuel savings. And that was definitely great for us. And then we validated that definitely equates to what we proposed, what our simulation showed, that our technology could provide 1.5 tons of fuel saving, or approximately 5 tons of CO2 emissions reduction per wing per day. Along with wind wings, BAR doesn't have that. That's not the only technology that extract the power of the wing. We recently developed a new type of superstructure, which again takes some, let's say, like, has its wind is in intrinsic nature and can provide up to further 2.5 tons of CO2 savings per wing per day. And secondly, BAR has also been advocating that although these wind-assisted propulsion systems are great for retrofitting, can provide great fuel savings and emission reductions, but if we redesign your vessels around these technologies, you can further enhance these savings. And this is one example of one study that BAR did that. So for example, this is a tanker. When we fit it on the baseline designs, the wind wings, the 4 wings, we could achieve 15.9% of savings in terms of cost savings per cargo mile. And when we connected with both wind wings and the aero bridge and optimized it, the shape of the vessel by keeping these wings at the center of the design, then we could approximately double the savings. That shows that, like, in the future, if we should start redesigning these vessels. So with this one, I would like to conclude and give a comment that definitely it's an exciting technology. There's a lot has to be developed, and I think it's just the beginning of this exciting adventure. Next Monday, the BAR is also revealing its new wind-assisted propulsion system, specifically for the smaller vessels. And if you are interested in knowing more about it, we would be next week at SMM, and you can come and visit us to learn more about this new device that we will be releasing next Monday. Thank you very much.
Thank you, Mr. Shahroz. We are also excited to know about it, and thanks for revealing it over here.
Thank you.
So next, we have Mr. Makoto. He would be elaborating the role of wind propulsion in the Blue Sail project at MOL, and also the impact it has on the shipping industry. I think MOL is one of the pioneers in the wind-assisted propulsion system installations. Over to you.
Hello?
Yeah, we could hear you now. Yeah.
Okay, you can see that. You can see the slide.
Yeah, we
Yeah,
could.
thank you. My name is Makoto Yamaguchi. Yeah, I have a job in MOL since 1991 and always working for the technology improvement of the shipbuilding and the shipping project. Today, I'd like to introduce our developing energy-saving device, Wind Challenger. This is a rigid sail type, same system as the technology, but maybe looks different. But I try to explain even the technical side and also the commercial side. But time is short, so that I am not sure that I can explain enough. But I am appreciated your patience and listening to my presentation today. Maybe as you know, the MOL is the shipping company. We own the very different type of the vessel. Total number of the vessel is almost 800. But also we are doing the development of this ship, the wind-assisted devices. I think this is a unique point. To be honest with you, our development is very slow. I'm very jealous about the technology. So they are developing this very quick and also very looks very beautiful. But what we are doing now is to discuss internally about what's the most important development about the safety and also the performance and the cost. First, we have to be very confident about our products, and then maybe we can go to sell to the others. Until then, I think we install our vessels and to confirm our performance, and then maybe we try to enjoy that kind of the value, and then finally we are going to the market to sell. That is our strategy. Okay. Actually, in this July, our second Wind Challenger vessel has been delivered and will be more for the next year and later. We will expand the fleet with Wind Challenger and continue to make Wind Challenger to be a best performance and competitiveness. Will then provide the value to the maritime industries to support other company effort to reduce the CO2 emissions significantly. But I think, as I mentioned, we are very slow. So um, anyway, we try the best and to make the good products anyway fast. But I think what I like to say today is about we are not started just now, just very in a very short in a short time. Our development has started since 2009. At the time, so many people say what is the wind assisted, what is the wind propulsion, or what is the wind assisted devices, and also some people after the analysis, some people say, "Oh, this is not working. It's very costly. It's very dangerous to be on board." So everybody doesn't believe it happened. Uh, but now we have the second vessel, and we will expand our fleet with the Challenger. That is very important, and this is a very careful step. Is I can say this is good things because wind assisted devices is looking very simple, but I think it's not so easy system because we have to be safe against the very uncontrollable nature, the marine wind, and also many seafarers say, okay, they have to keep the time to reach the next port. So how much the impact by this wind propulsion system to the navigation? I think still under investigation, still under the study. This is a very important point, and this is advantage for us because we are shipping company. We have internal the seafarer employees, so many. They have many opinions. They have experience to work on board with the Wind Challenger. So then maybe we collect a lot of data from this vessel. And then maybe we again and day by day we are doing what is the more better Wind Challenger and what is how we can navigate with the Wind Challenger and to make a good performance. That is our target.
Yamaguchi-san, your slides are not changing. Is it still supposed to be
Okay.
slide? Maybe
Okay. Now what you see that latest information?
slide one. Still slide one. Ashla,
Okay.
can you please change?
I'm not sure if I can. He has presented from this
You
end.
want to try full screen of your presentation and then try changing?
Yeah,
Still in slide mode.
So what is the slide now? Now the
it's
top
the
one is
first
the
slide.
latest.
Yeah, it's the Wind Challenger project for
Slide
future
one.
maritime. Yeah, slide one.
Slide one. Okay. What's that?
Yeah. Now it is slide 6.
Slide 6 now. Okay.
Yeah.
Yeah. Anyway, it's not a big change. Thank you very much. Yeah. And I like to provide you the performance of our Window Challenger for last 2 years. Show our next step to go forward with the window-assisted device. Window Challenger recorded so far the saving of energy by the 17.1% one day average. Highest performance was more than 30%. If it was the 5 to 8% by the route by the voyage. Think that's the mileage, which can be increased
I believe there are some sort of technical issues from his end. We shall begin once he's back in.
Okay.
Sandith sir, you could ask a few questions if
Yeah. So
um,
I can do that
yeah,
while he's back. So
yeah.
there is very interesting point what Gavin mentioned, which is like pay as you save approach, or what you call as a lease model. There are all questions related to that. Gavin, if you can hear me, do you know anyone who is offering pay as you save approach for WAPS? And also related was like the biggest barrier to adoption of WAPS technology seems to be high capex. Do you have a leasing offer, or do you know anyone who does that for ship owner? And maybe Satya will this next same question with to Satya has come in, like, have you looked at lease option or pay as you model when you were evaluating? So this is all related question. Gavin
Yeah,
first.
Yes, sure.
Gavin, maybe you can take it first, and then maybe I can
Yes,
add
sure.
in.
can
Yeah,
can you hear me?
yeah,
Yes.
we can, please.
Great. So, yeah, on the first question around the pay as you save model, there has been work done on that, and there are a couple of models that are actually available, if you like, but they haven't been utilized to any extent. One of those has been developed by HHX Blue from Professor Orestes Shinas. And there is some work, I believe, going on at the Global Center for Marine Decarbonization in Singapore. They're actually going to be piloting this and looking at this a little bit in more detail. So that's that aspect. On the leasing side, my understanding is a number of the companies within IWSA are offering some form of leasing. I know one of the rotor companies has been doing this. There's a containerized suction sail system that has been looking at that as a leased option. So yes, they certainly are, and I think I could probably say to for every company, and I apologize, Shahroz and Makoto, if I'm talking for you, but I think that every company would be interested in having that discussion. Is that a potential option? And the key thing is the de-risking of it. And if I could just make that last point is when small companies or smaller companies are delivering the systems, then there's always the issue of is that company going to be around in 5 to 10 years? So a lot of the companies are joining up with larger companies, having service and maintenance deals with companies like Wärtsilä and other large suppliers. So it's that de-risking for that longer period as well. So just taking over from you there a little bit, Makoto, while you fixed your technical.
Yeah,
Just before
it's okay. It's okay.
Yamaguchi-san answers, like Satya can give his
Yeah.
perspective on that.
Yeah, while we were evaluating as for our organization, we found that Econowind was offering that containerized model on a rental basis for 6 months and or a year, depending upon the requirement. And they also had an option of, for a permanent installation, one can opt for a leasing model. So I think there are other companies also will be having a similar option provided. One needs to check that. The challenge is that rate of interest fluctuations is one thing one need to take care about, which is when we started the talk it was different, and then over a period of time it bumped up. But that is one thing one should consider.
Okay. Yeah.
Yeah.
Okay. Yeah, Ashila, you can.
Yeah, Gato-san, can you present your screen? And we are sorry for
Oh,
interrupting. You
okay.
just
Yeah.
went
No, 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 no. It's okay. No, it's okay. I also very interested in the question from the user. Yeah. So okay. Maybe you can see that slide.
yeah, we could.
Yeah. I think maybe I also like to share the our YouTube.
Yeah. This is the fifth slide.
Uh, the movie is going. YouTube.
No, it's not. I think we could only
It's
see
not.
your PPT.
Okay. Just as maybe I need to skip. Yeah. Okay. Because I like to show you the what's the process of the developing the window changer. It's quite okay. In the beginning, I explained this is not the easy system, so it's spending a lot of time on to the very structure is a very robust on how we can build that kind of the system. So that's movie, but I think maybe you cannot see that. Maybe I like to skip. Sorry about that. Yeah. Okay. Okay. What like I explained. Okay, I skip this one. And also, maybe you cannot see. Okay, this is our character. A wind challenger character. Still, you can see that.
Yeah, we can see.
Okay. Yeah. Okay.
Uh,
Like you can see that. You can see like that.
we are in slide 9, but not the video.
Face is necessary, but sometimes very strong wind, or okay, you have to go very narrow straight. So in that case, you can make this wind is the to minimize the maximize the thrust power by the wind. So this is the most important function. Also, another important is that we use the composite material for the each the sails. The composite material is quite much lighter than the steel materials. So if you like to have a large this kind of the sail, maybe without using the composite materials, maybe very difficult to control, and also very difficult to keep the safety, so no collapsing or no controlling on time. So so that is why we decided, even a little bit the cost is high, but we decided to use the composite material on this Wind Challenger. These two challenge or this two technology is very important for the Wind Challenger to fulfill the target. So yeah, that is very important. Also, performance I already explained. Yep. Okay, another point is okay, you can see that I think this red color area, no thrust generation, only 50 degrees of wind from the forward. But the other area, we can create the thrust power by the wind because the wind challenger cell is always rotating, then rotating to face to the best, facing to the best direction of the wind. So then they may be even smaller or even bigger. So we always moving to get the wind power to the thrust. So that is another function. So this is three important character is the to make the performance of the wind challenger. Yep. But even so, I think we have to challenge still. We have to challenge many things. Still, many people doesn't understand the how to operate the what is the character of the wind assisted devices. So that is why we started to do the kind of the educational approach and what is the wind propulsion system is. It's going to the IMO, it's going to the other the exhibition and any event, and I try to explain what is the important of the this is Gavin san will agree with that. The another point is the um reliability, because very new products. It's not only MOL but also other many companies doing the this development. But we have to get fast the reliability. It's quite a big system on board. Once trouble happened, everybody lose this reliability. So that is why we carefully design and carefully operate this kind of the system. So that's we are doing now. And the last one is the price. Uh, I think currently the cost is very high for the Windows Challenger, and also maybe other Windows device cost is very high. But making the many mechanism of the price down, so then finally we can if Windows Challenger or other device competitive. So then we can install the vessel as many as possible. That's 3 point is our challenge now. Okay, for the window challenge, that's all. Thank you very much for the okay, to listen my explanation. Thank you very much.
Thank you so much for your presentation. We did have a lot of glitches here and there. Like you mentioned, it's a little humid back in Japan.
Yeah,
There was a lot of humidity with your network as well.
thank you, thank
Uh,
you.
but it was great hearing about the installation, about the MOL. Next, we would have Sati sir on to the stage to present about a lot of things, a lot of experience that he had from the Great Eastern Shipping, where they had reviewed few of the technology providers. He'll be sharing his case study on that. Over to you, sir.
Thanks, Ashila. Do let me know once my screen is visible.
Sure, sure.
Is it visible?
Yes, it
Okay.
is. Yes, it is.
Ah,
Yeah.
yeah. Okay. Yes.
Yeah. Is it visible now?
Yeah.
Yes, it is.
Yeah, yeah. Thanks. So, we are just to give you a brief introduction of our organization, we are the largest private sector company in India, and we have been involved in decarbonization research for our organization, trying out new things, exploring new options, whatever there in the market. Wind assist also we checked into many technologies and still contemplating on this. So just touching upon suction sail technology in this presentation. So, uh, if you see, this technology is quite different from bar technologies and rotor sails. There is a small clipping I am trying to play in this one. Uh, the shape of the wind sail, it's just like an egg shape design, and when the wind is blowing across the sail, there is hardly any drag. So it is just like a non-performing device. But as soon as you have suction involved, where you suck out the air through these, you know, passages and remove it, you will find that the lift is quite high, and that provides the thrust for the vessel to move forward. So this is a small clip from Bound for Blue. There is another photo from Econowind. They have a small containerized model option which I spoke about. It's a rental option. So if you see, if the wind is blowing from port to starboard across the sail, there is a blower at the top which tries to suck these airs and provides the suction effect, and that leads to a thrust force being developed, which assists in the propulsion of the vessel. So both these Bound for Blue and Econowind, they have design with blowers at the top. But recently, Econowind in their newer design have installed small blowers of lower capacity across the sail at various locations. So this is their concept. This concept was, it attracted us only because it is comparatively having less capex. I'm just trying to show you the components involved in this sail. At the top, as I discussed, there is a suction fan provided. It's blower which is trying to suck air from the suction area, which is grayish region in this photo. So across this grayish area, there are small openings which are providing air to move inside, and then through the suction fan, it is being pushed outside. There is a flap provided to control the opening. This is the main structure. They have automatic control system inside this sail, and there is a rotation system also inside. There is a flange connection for fitting it to the deck at the bottom. They have various sizes of sails from both the manufacturers, from 10-meter to 36-meter tall, costing between 200K to 900K per unit. This will vary. This is just the cost of the sale, but you will have to add the overheads like foundation work, yard charges, class fees. All those need to be taken into consideration. We had done some kind of preliminary evaluation for a capesize bulk carrier through Bound for Blue, We provided them 1 year data of our vessel, and they had come back with these results, which they have considered 10-year wind data and 2 units of 36-meter sail, vessel operating at 13 knots. So if you see, for various routes, they have shown savings. Most of the savings, if the vessel is making a cross-Pacific, cross-Atlantic voyage, the savings are much higher. Like you say, from Norfolk to Algeciras, the savings are close to 4.2 tons. Similarly, when you're making from Mexico to Latin America, it is 2.46 tons. But if you are having a voyage which is, you know, uh, closer to equator, the savings are reducing because the wind, there is a thumb rule that as you go move away from the equator, you have lesser and more and more benefits from the wind assist propulsion systems, irrespective of which technology you use. But closer to equator, the benefits are on a lower side. So this was for bulk carriers. Similarly, we did a study for a Suezmax tanker uh, through them. Here also, if you see, they have considered 2 units of 36 meters. And if you see this voyage from Los Angeles to Panama, hardly any saving. But if you consider from Lima to Rio de Janeiro, the savings are much higher. So closer to equator, like I said, savings are not so attractive. So one has to really consider what trading pattern of vessel we are looking into while choosing, a technology, wind assist, if you want to install for that vessel. you know uh, we have, this slide I have tried to cover, while evaluating what technology or VASP we have to fit. There are certain things we need to take into consideration. First is, basis the size of the vessel, which type of VASP will be suitable for every size. The size, for every different size of vessel, the sail size or height will be different. One has to do a proper feasibility study to understand the benefits before, deciding on it. Then certainly the wind direction and the speed, which will always depend on the trading pattern of the vessel. So if a vessel is having short voyages, then one should, not consider wind assist. If it is on a long voyage making cross Pacific, cross Atlantic runs, then certainly one has, it is a very attractive option. uh, Also, percentage of sailing days. So if vessel is having more sailing days, 60 to 70%, that is a good choice vessel. If it is between 30 to 40% sailing days, then one should maybe think of other options. One has to consider the air draft restrictions, coming during the river passages. So if your vessels are moving into those regions, then better to opt for a tilting type option. Otherwise, it becomes a challenge during those operations for those ports. One has to consider the visibility for the navigation, line of sight. uh, this has been taken care of by use of CCTV cameras and all, but this one has to certainly uh, do the proper evaluation during the feasibility study. Then there is interference regions. So if you see, if the vessel is having a more freeboard, it will create an interference effect, and the lower portion of the sails will not provide you that much benefit. So maybe you can have pedestal uh, over which you keep install these sails to maximize the benefits. Otherwise, you will have areas which will be underperforming from the sails. So these red mark regions were highlighted to us during our study as having interference regions for the vessel which we were evaluating. So every vessel will have different challenges on this regard. Then there is a aerodynamic interaction. So two sails will have their own interaction influence over each other, and the combined savings might be on a lower side. So how to place these sales, how much should be the gap, that needs to be evaluated during a feasibility study. And certainly the additional power requirements. So every design has got certain amount of power requirement, whether your existing generator will be sufficient to cope up, or you need to install additional generator, or opt for a sharp generator installation. That one needs to seriously consider. Otherwise it becomes a maintenance issue for the auxiliary machineries. Then structural strength, one has to provide the under deck strengthening wherever you are installing this uh, technology sales. So we had to go to the class to and fro to understand their rules, because every class has got different rule structure for the structure strength, and each class approaches it differently. So better to involve class whenever you are thinking of doing this beforehand, so that you save a lot of time. The two manufacturers we had contracted was one was Econowind. Econowind has a permanent structure like this, which is a folding type. Another one is a portable one, where they are having 10-meter sails in a container, two sails in a container, which they provide on a rental basis. I'm not sure that whether they are still doing so, but a couple of years back they had this option: 6 months rental and a 1 year rental. Another one is Bound for Blue, which is also having permanent or tilting type of structure. Both options are available from this manufacturer also. That's it from my side. Over to you, Ashila.
Yeah, thank you so much. That was really good to know about other providers as well. So I think we are, it's about the time that we start discussing the questions. We have few excellent questions in the LinkedIn. Sanditha, if you could.
I can take over here. So there is question from Atul Kumar. It's not addressed to anyone, but I think Shahroz is best suited to answer it. So if wind power is being installed on a ship and is generating lift adding to propulsion power, which other aspects like the shape of bow and other factors play in the part of propulsion that would be modified, need to be modified? Is there anything that needs?
Yeah, I mean, like, if you are saying from the what I mentioned, from the early design phase, if you really want to optimize the shape of the vessel to get maximum gains from it, there are, I mean, so wind itself, like, so the designs of the wings or the design of the WASP structure, it's one design problem, and the design of the vessel is another problem. So what you have to do, you want to integrate it. So from the design of the WASP itself, there are various factors, as Satya said, like there's an aerodynamic interaction, there is like how the shape of the wing itself has been designed, and then there is a factor related to the hull, which is like how we can reduce or increase the savings or reduce the drag and increase the saving from the shape point of view. So in order to find the correlation between two, like we have to do more research from that side. Like what I cannot say something like, okay, the bow of the hull was affecting or providing some significant gains towards the WASP. Okay, or that specific part of the WASP was providing significant gain towards that, like the bulbous part of the hull. So that's like a hard question to answer, but definitely, let's say, like when we want to work all together, let's say, like design both system from the outside point of view, and there we can understand, let's say, like which factor or the which feature of the bow is affecting on the shape of the wasp, or the which shape of the wasp is affecting on the form of the vessel. So then we can answer this question more effectively, I think.
Okay, all right. Okay, so there are two different questions. Uh, I would say three are all talking about the same thing of assessing the savings. So one was to Shahroz, like when you specify savings in 1.6 tons in fuel per wind wing per day, how do you measure? And similarly to Yamaguchi-san, like when you specify savings of 17.1% for in a day for Shofumaru, how do you measure it? And when I say measure is like, how do you also discount the cost of power? And also you are making an observation, like suppose you install this and you're observing that today there is a wind from a particular direction, and you're needing total engine power of say x horsepower. If there were no wind on the vessel, you are assuming that the power should have been more. So that's your assumption when you say either the fuel would have been more, or the in percentage or in quantum. So how do you step by step measure is what the question is trying to do. This is also probably Satya, in your point you said about that Bound for Blue had taken a 1 year data and did simulation. You gave the data and then they gave the result stating this is a saving. But do you know that what steps they did? Is it a black box result, or do you have step one, two, three to recreate the same result? Is all questions are similar, so if each one can go one by one to educate people on how this benefits are computed. Yeah, maybe starting with Shahroz.
I think, I mean, like I can only talk from the point of view of bar technologies, and I'm not sure that like if there is, I think there is a more of a standardized structure, but if there is a standardized structure that has been placed through all the wind assistant stakeholders or the key players. So definitely that's like, I think the what Satya showed, that we do the same. Like we take, like when a clients come into us, we get their all the historic data, and then we say that like which routes that vessel goes on, and then we identify that. If we say that like these, and then we look at the historic data like of 20 years, 10 years, whatever is available on that route. And then we measure that. Like, and then we see like if there is a sufficient wind on those routes, and that's the on average the most amount of the route the vessel will be sailing on doing the voyage. And then we say like, okay, we're gonna take that vessel, and this vessel could be a good fit for such technologies. And from there, we run all of our simulations, take into account the data that we get from our customers, and then we take into account the weather data. And then from there, we run all of our simulations to see, for example, we have our VPP, Velocity Prediction Program, which gives us the polars, and that polars, we add the data that we get from the clients, we get to those polars, and the polars that do this voyage simulation with the wings on and throughout various wind conditions. And that difference, that's like what vessel had consumed on that route and how much we are getting with the wings on and wings off. Okay, then that the difference, that's like holistically speaking, then that the difference gives us an indication towards fuel saving. I mean, like, I cannot tell you the entire pipeline, but holistically, that's our approach is.
Yamaguchi-san, you want to add anything further on this methodology? We're not able to hear.
You're on mute.
Yamaguchi-san, we can't hear you.
Can you hear me now?
Yes.
Can you hear me now?
Yes.
Okay.
Yes.
Sorry. Yeah. I think there are some points because for MOL case, we are developing together with the shipyard about the Wind Challenger. So it's quite a very important time just before the delivery. Maybe the shipbuilding, they do the sea trials. I think we made their plan to do additional sea trials about the Wind Challenger. So at the time, we try to measure the different data with Wind Challenger and without Challenger, so making many curves. And then finally we found the very basic data, but without Wind Challenger line. after delivery of the vessel, we collect a lot of the data every day or every minute. So then maybe how we can deviate from the that base, so that we can measure it. So I think 17.1% is the day average. Okay, that's a very important day average. So we can get a very good data, because one day long you can get a very good wind direction and wind power. That is possible, but it's not always every day. So finally, you have to understand around for wind challenge case 5 to 8% for the by the voyage. So I think what I like to say is one day long, if you can get a good day, good wind, so then we can increase that data up to 17.1%. This is a potential of your wind assist system. If you can choose the good direction with the getting the good wind direction and power, so then you can increase your reduction. You can decrease the consumption of the fuel. That is very important point. So that's why how to measure is a question. Yeah, okay, we can check in the beginning of the vessel, beginning just before the delivery, every many times of the measuring and to making the curve and to find out our data without wind challenge influence. So then we can
Yeah.
check the deviation from that. Yeah, that is very simple idea.
Okay. So, Satya, when Bound for Blue gave you this 1 year data results with simulation, did they give it as a very transparent way of assessing with and without, or was it a black box?
No, actually, they had clearly mentioned that we will be picking 10-year wind data, which is available from the European service provider, EC MWF. And basis that data, they will see how the wind patterns have been for a specific voyage over the period of years. And whatever the vessel, if that voyage is made, every day the savings will not be same. One has to understand that in wind, even every hour also it can be different. So this data, what savings is projected, it is an average per day data for the whole voyage. So there will be cases where you will be getting 5%, there will be cases you will be getting 15%. So the software is not providing you that accurate data, that is just providing you for a voyage how much will be the average savings data as per the route and the wind pattern of the vessel, basis the route what it is being taken, and the installation, how much height installation or size of the sail you have opted for. So this was a simulation, so they are using their software. But what actually MOL has done was actual measurement after the installation. So both are entirely different. So if but they had said that their simulation and their actual implementation was having very less error. That is what they had mentioned during our evaluation.
Gavin, I'm just making this comment because you are the greatest advocate of wind propulsion technologies. I feel that what came out due to ISO 1930 to help ship owners evaluate energy saving device or a high quality paint, etc. Now all paint contracts are written on 1930. We need something like that for wind, because wind you cannot use ISO 1930, and that is also a factor, because when I ask this question, I still get that the methodology of arriving is still a black box. It is not precise, independent, and everyone follows one standard. Maybe it is interest of all the technology providers as well as advocate like you, that one standard emerges, so it becomes transparent to the eventual person, user, or the person who puts the money, like ship owner, that the numbers that is being said is what it will be, because you can never assess post facto. Even if you install, it is a theoretical assessment, like this would have been the savings, right? So to avoid that, maybe it's interest of all of us. We are all interested in adoption of wind propulsion. That something emerges out. This is just my comment. Maybe some food for thought.
Yeah, I can give you an update of where we are with that. So
Okay.
so we've got I'll give you three factors that are developing, and then I'll make a comment about what's been said. So first of all, we're in contact with ISO. There is the development of an ISO standard around wind propulsion, and we are liaising with them on that. So that's under development at the moment. For the standardized approach, this is part of what the GFI submission is about, is that we are proposing not just to start with a standardized way of calculating the amount of power that is being derived, because we have different systems operating in different ways. For example, a kite is operating at 300 meters where the wind is blowing all of the time. But how does that then translate and calculated with a deck-based system? And another point that will be coming out next month, September, is the ITTC, which is the International Towing Tank Conference. They are developing, or have been developing, some guidelines or recommendations for sea trialing, because of course usually a sea trial is done around with a very flat sea with no wind. Not a great time to actually test a wind propulsion system, but also some guidelines around how to assess and verify the development of this. The power derived from wind propulsion systems. This is an ongoing process, and we have some assessment criteria, for example, in the Circular 896 from IMO, which is around EEDI and EEXI, but it's insufficient, and it's not good enough for all systems at present. So it's an ongoing process, but we are very much working towards standards. And if I could just make one other comment, is all of the classification societies, all of the major ones, now have wind propulsion guidelines. So if you are interested in your installing of systems, you can go to their website. We have links in our newsletter every few months as well. You can learn the guidelines that are required for those system installations. But also, class, we would like to see an aligning of these guidelines ultimately in a wind code, a standardized wind code, but that will take a few years to actually develop.
Yeah. Okay. Thank you for that update. There is this question to Yamaguchi-san. As a pioneer and early adopter of wind-assisted propulsion, what were the primary factors that influenced your decision to implement this technology at MOL?
Yeah, thank you very much. Yeah, very good question. And I believe it is without mistake, it is the cost. I think our target is our device is a rigid cell. So for the character of the rigid cell is as large surface as possible. That is the quite influence to the performance. So which means the maybe lesser cost comparing with the other devices. But if we can solve the problem about the higher cost, so then maybe it can be a very competitive. That's what we believe. So now we are discussing a lot with the partners how we can go to the mass production. Still, we need many things we have to challenge. So, but how we can reduce the cost, which is how we can produce our window challenger. How many we can produce it. So that means I think mass production is one of the way we can reduce the cost and to be the competitive. So that is our challenge. And also first important task is about the cost. because we already confirmed the performance, we already confirmed the reliability, robustness, many things now. Important now is how we can reduce the cost. So that's our challenging. Yeah, thank you.
If I add something to correlate that, I think most of the players here, those who are developing this technology, I think the focus mostly has been towards making these devices more effective and efficient in terms of achieving maximum gains. And I think now we would have to focus along with that. I think we have achieved good performance in that perspective. And I think now we have to start looking on our designs, like how we can reduce the cost itself. So it's like integrate manufacturing related criteria and constraint really from the start. And then try to create the data that, for example, the example that I will give from, at least from the bar technologies, that we have been gathering a lot of data from the both vessels. And then that data we're not only using to create better operation strategies for the wings and also to improve the design, but also using the data to reduce the manufacturing cost. And for example, the product that I said like that we are releasing the coming Monday is that the focus has been to keep the cost at a very minimum level. So that is the same objective as increasing the gains, and along with that, at a similar level, also to reduce the cost. So I think so these should be run along together.
Okay.
So I saw that part I already explained during my presentation. So I agree with you. How we can improve the performance, still we are doing, but I think anyway the cost is quite the key.
Yeah. Gavin, there is one question regarding that policy you already. I think Gavin just stepped out. Okay. I hope he comes quickly. If not, we can go to the next question, which is related to. Is he back? Okay. Which is related to the numbers which you have given, both of you, Shahroz and Yamaguchi-san. So the question is, can you share the capex opex savings of one of the installation? Example to Shahroz was the wind wings for Berg bulk, and to Yamaguchi-san was Shofumaru. Capex opex to give a feel of the. I saw somewhere it's 5 years, 5.5 years. So can you give a feel of these numbers?
For me, still okay. I have to say they are still keeping the confidential because we only have two, and also internal use only now. I think once we have to go to the market, maybe of course we disclose everything about that, but and maybe it is after our effort to reduce the cost. So that's why at this moment we cannot say that. Yeah.
Okay.
Thank you.
What about you, Shahroz? You have
Likewise, I think I would stay. Yeah.
You are not helping
Only
us to
towards
decide.
Yeah, I'm like being an R&D lead, it's a great opportunity. You get an opportunity to think wild, right? And then in this wild thinking strategy to improve the performance of the wings, then you kind of put that effort towards the other member of the team that they care about it, and then we focus on bringing really state-of-the-art technologies and approaches to construct the most efficient product.
Gavin, you can see how the engineers are reacting to asking numbers, right? So, how will anyone? How will Satya take a decision?
Yeah. So
Gavin,
I could give you maybe some general oversights on what this. So one would be around of fuel really makes ROI around the sort of 3 to 5 years. The magic number here that we've seen is around about $600 per ton of fuel. Now HFO is below that. VLSFO above and below that. MGO and LNG have been above that for quite some time. Now, if you factor in the the EU ETS, for example, at a 50% level, but only at the 0.4, which is this year. We have the 0.7 and then the full one in 2026. Then by I think next year, that pricing would push HFO above that $600 mark. And that brings in, so what we use to look at this is a bigger system will be more expensive, but will give you more power. Smaller system, a cheaper install, less power.
And when you
But
go ahead.
perform a little better. Some systems will perform a little worse. So, but that's one way to look at this. If I could just mention one other thing, is we also need to, I think Makoto
Cannot hear you.
Yeah, Gavin, you are not audible now.
Okay, am I back?
Yeah, you're back.
No.
Yes, go ahead.
Yeah, sorry. This is I'm in a Swedish hotel room at the moment, and it is not the best. So if I could just mention one other thing is, if we are looking only at today's ROI, that is a challenge. We've got to be looking at the regulation coming in, the likely fuel prices in the next 2 to 3 years. And also during that period, as Makoto and Shahroz mentioned, we've got the economies of scale and the learning curve, which is reducing the cost of production. Of course, energy costs we can't predict, but generally is around about a 10% reduction for every doubling of installations. So in that matter, then the ROIs are reducing quite substantially within the next 2 years.
Yep, I believe so.
Gavin, when you say ROI, you use the number 600 as a magic number. I want to understand, at 600, you are saying it will break even in 5 years, 6 years. What is that outcome? This is one question. And second is, you said the change in expected turbulence in fuel price, etc. Of course, in your ROI, you will build that model. You are going to say this year is $10,000, next year is $15,000. So when you build a model, you can factor that as well. What is your future five-year expected savings when you translate to money? You can build all this in that regulatory pressure. Everything can be built into that model. So yeah, go ahead with that first part. $600.
Yeah, it's quite okay. So it's quite interesting that wind propulsion is always looked at from an ROI perspective, but new fuel use isn't, and yet it's the same propulsive approach. So, for example, an ammonia-powered vessel or a hydrogen-powered vessel or a methanol-powered vessel will never be cheaper than the systems that we're using at the moment, or won't be at least for the next decade. And yet that isn't the consideration. So that's just one of my beefs. So I'll leave that. I won't go into that anymore.
No, I'm only talking how the ship owner might think. I really don't know how they think. Maybe Satya can tell. Finally, the money that matters.
No, indeed. So
it.
yeah. So the $600 mark basically is bringing it into the 3 to 5 year zone. So 3 years, obviously, any system that's 3 years or less is a very easy discussion to have. 5 years, becoming easier, or certainly a discussion to have.
Okay. So that's good. So there was one question again to you, Gavin, which is regarding that fuel EU policy support, which you mentioned. There is one very specific policy adopted. Is that more like if you just install, you get the benefit, and not necessarily that you have to establish the saving, right? Is that what I understood? Or?
Pretty much, yes. But of course, if you use the system, you also get the reduction in the fuel use in the formula. So this is an added bonus, and from my understanding, from the calculations that I've seen, this can be anything between thousands of dollars to tens of thousands of dollars in the operation. And the actual penalties. So what this does is it means you don't have to pay the penalties. Now the penalties are stepped in. I don't have the exact numbers of how expensive that becomes, but by 2050, it's very, very substantial. I mean, it's extremely high, $1,000 per ton of CO2. Okay. But in the early days, it's lower. So we're looking at probably tens of thousands of dollars for a medium-sized installation that can be saved. For a large one, potentially hundreds of thousands. But the key thing here is that 2030 is a 6% reduction in the carbon intensity of your vessel. Wind propulsion, if you put on a system that delivers 15% or above, you get a 5% reward factor. So you're pretty much compliant at 2030 without doing anything else. We want to see that reviewed and strengthened, and the review process is already starting now. RFMBOs, which are the renewable fuels with a non-biological origin, these get a 2 times multiplier within the formula. So wind propulsion.
Okay. Yeah. Okay. So there is one question regarding maintenance side, which probably Shahroz and Yamaguchi-san can answer. What are the maintenance requirements and lifespan of these WAPS systems? Owners and managers are concerned about the system going effectively, efficiently, without much effort. So you want to tell something on this maintenance side?
Yamaguchi-san.
Okay.
Would you like to go ahead?
Yeah, I will do. I think this is quite a discussion internally we are now doing. And first, we like to explain the mechanism. I think all wind-assisted devices, basically we can say autonomous, auto-controlling, so against the wind. So from that point of view, the seafarer is usually not touch that system, just monitoring the system is going well or not. So if there is if they found some problem, okay, stop the system to check. But basically, it's not so many news coming like that. But so that's why basically it's quite automatic. Also, but the other point, very very simple maintenance, because of the system is there is a rotation mechanism, or some of our cases the telescoping mechanism. Sometimes seafarer have to check the condition inside the oil or motor or electric, such kind of a very simple checking maintenance is necessary. But overhauling is still very, very young. System is very young. Now we will find out the 5-year interval or 10 years interval, or that's we are discussing now together with the shipyard. So that is going. So it's not so big burden because automatic, but maybe we need to monitor what is really necessary after 5 years, 10 years. So still we are using even after 10 years. So that is still our idea now. Yeah, thank you.
Yeah, I mean, like talking about the overall lifespan first. For our wind wings, it's 25 years without any major part replacement. And same what Yamaguchi-san said, our system is also fully autonomous from achieving different configuration based on the wing conditions to achieve maximum lift. Towards handling failure mode, vessel blackouts, towards lowering down the wing, tilting down the wings, towards putting it up when the operational conditions are reached. So everything is fully autonomous. And also For over wind wings on board vessels, they have our in-house built system called ship seat. So the ship seat is doing all these plannings for the user itself. And it's also giving real-time route optimization, taking into wind conditions all the time. Everything is fully autonomous. And also it has a maintenance module, both performing predictive and corrective and preventive maintenances. One interesting thing that I also mentioned, I think, earlier when we met, is we had a conversation with all the maintenance engineers on board. And they said absolutely that they don't feel any burden on themselves that they have to take care or to count, like further complexity has been added towards the system. So they say like they are performing their duties like as they would do for any other vessel. So there's nothing has been added, no complexity has been added to perform their duties or their maintenance tasks.
Okay. Okay, Satya, this is a question to you based on how the wind is. How do you weigh the advantage of wind system propulsion against other environmental and technology options available for your fleet? This is a question typically to a ship owner. See as a wind versus the rest.
Yeah. So, like I had mentioned in the presentation also, that for every vessel type, it might not be suited, because one has to consider the ship's trading pattern, how the vessel is trading, whether the sailing days are very good, because some vessels like MR tankers, they are hardly doing any voyages, short voyages, then the ship VASP technology will not be suited to that kind of vessel. But if a vessel is going, cross Atlantic, cross Pacific, long voyages, maybe having 70, 60, 70% of sailing days, that is a very suitable candidate for considering a VASP. So one has to evaluate what is the trading pattern, what type of vessel we are looking at, and how much is the residual life of the vessel. If I am considering my vessel which is already 20-year-old, maybe I should reconsider my option, maybe pick a 10-year-old vessel, so which is having a maybe next 10 years in my hand. And even if my ROI is coming to 5 or 6 years, it is still giving me a decent amount of benefit. Going forward, you will be seeing carbon tax coming in from IMO. EU has already come up with the taxation. So all these carbon taxes will make these ROIs come down from 5 to 3 years. So anything which is showing 5 years now, it is basis fuel calculation of maybe 600 or 650 USD, but you have not considered the carbon tax or EU taxation or fuel EU maritime into that calculation. Coming that taking that into picture, this will come down to 3 years and it will make more attractive. One more thing is there, that these installations, most of them can be removed and put it on another vessel. Suppose 20 years later I am selling my vessel, but I will be buying some other asset, there I can transport it. So this asset is not a dead investment. Like
Yeah.
if I am installing air lubrication system in my vessel now, it is going with the vessel. It cannot be shifted to another asset. Whereas in wind assist, you have a very big advantage that you remove those sails and put it on another asset. Apple to the same trading pattern and same size of the vessel. So this is, one has to think of long term and pick and choose vessel which are as per trading pattern, which will give you which where you can maximize the returns.
And seeing your presentation, I somehow felt that you have a preference for suction sail as compared to, let's say, hard sail, since the other two experts are from hard sail. So what is your
Yeah.
reasoning for that?
So actually, all these technologies are new. Everybody will agree that rotor sails was there in market, but rest all were new. But we felt that instead of having so much capex, let's explore the one which is having a lowest capex involved. And we started thinking of doing a trial using a containerized option of Econowind. It didn't materialize due to various reasons, but that was easiest way to test out the technology for the trading pattern of our vessels, whether it is giving us the benefit or not. but it attracted us because of lower capex involved. That was the first reason.
Okay, understood. Yeah. So
Could
there
I,
is,
Sandith,
yeah, sure.
could I just make
Yeah,
a couple of comments? So thank
yeah,
you,
yeah.
Satyakumar. There's a couple of around environmental technologies. One and the impact or where wind fits into that. I did mention it during my presentation, but I just wanted to reiterate the additional point: is wind isn't just a decarbonization solution; it is a solution for all emissions. There is no emission from wind propulsion energy or the energy used from wind propulsion. Of course, the technology has some impact, some embedded carbon in the systems themselves. But for example, underwater radiated noise, which is not being regulated at the moment, it will be in the future. With wind, you are able to bring your systems or your propellers down below the cavitation point, for example. If you're going for major wind issues, then you can really reduce the underwater radiated noise that you're generating. But also things like VOCs, volatile organic compounds, black carbon, even with the new fuels, hydrogen has a climate impact as well, though it's not a direct greenhouse gas. So wind has none of those issues. However, those are not priced into the market yet. So if we're looking at the future, we need to be looking at a broad spectrum of environmental benefits. One last thing is also, if you are looking at a new build option, if you've got a substantial wind application there, you're also able to potentially put smaller primary smaller engines and storage in, because you're going to be requiring less fuel. You're possibly going to be requiring less power on that vessel as a total. And the last thing I'll mention is you're also able to extend your range. So if you are bunkering, say you want to be bunkering at the most economically viable place, because you've got the wind on board, you can actually lengthen the voyage that you have that you need to bunker on. So you're able to pick and choose where you're bunkering. Most of these calculations are not put into a general ROI, but they really should be.
Okay. since you okay, Satya, before I ask Gavin.
Yeah, Sandith, I just wanted to add one thing. Many of the fleet vessels in the market presently are having non-electronic engines. 70% of the ships, they are having non-electronic engines. They will not be able to run or convert to run on methanol, hydrogen, or ammonia. There is no option for them to look out for options for decarbonization like wind, air lubrication, or others. If we don't look for wind now, it will be very difficult to overcome the challenges of coming regulations from EU and as well as from IMO. And the vessels which are having residual age of 10-15 years, this is the right time, maybe second survey or second special survey or third special survey, we at least make the vessel wind ready after proper evaluation and feasibility study, so that if the prices certainly come down in a couple of years, you can install it during sailing also, because installation will not require ad hoc. Main thing is foundation preparation, which the cost can be reduced during the special survey. So at least one can do a proper evaluation as a ship owner to understand what are the challenges and start the preparing for it. Because with alternate fuel also it can give you benefit. Without also it can give you benefit. Either ways it is giving you a benefit.
Yeah. Okay. Okay. Thank you. So now we are towards the end. So the last couple of questions. There is this question both either Yamaguchi-san and Shahroz or both can answer. Like key regulatory documents needed to review before or planning installation of wind system on vessels.
I think it's okay for our company's case. We develop together with the shipyard the Wind Challenger. So, but together with the classification classification is always contact with the government to check the what's the necessary regulation is. Also, they're checking the IMO regulation. So bit difficult to say the specifically the which part of the regulation you have to check, but I think basically you can contact with any classification. So there nowadays maybe some guideline or support of the wind propulsion system is mentioned in the classification document just as a guideline or just as a some. It's not a rule or rule base. So, but that document is helpful for you to understand what the propulsion system is, what the effect of the propulsion system, and also you have to check as a point there. You have to check the okay, like a fuel EU maritime or fuel. I think the EU regulation about the wind propulsion system. There is, as you mentioned, there is some. Some it's kind of their potential wind system has wind system installation is kind of the incentive in the formula. So that's why I think from that point of view how we can avoid the penalty in case of your ship is going to the Europe. So maybe I think that is another point. Maybe okay, you have to reduce the cost for by the installation. So that's why one is to approach the classification to check that's the window propulsion system. The another point of it to check the regulation or as a new requirement by the EU or the EU Maritime. So then they are maybe checking how much impact by the window propulsion system. So then you can see the effect of the window propulsion system about the economy and also the technology. I think, yeah.
Okay. So there is one last question to
I
Gavin.
could also, comment on the previous question. I would say, like, I mean, I fully agree with what Yamaguchi said. I'm not the right person, I would say, like within the organization to answer that. But definitely what Gavin mentioned and Yamaguchi mentioned, because now there are clear guidelines by the major classification societies. So you can straight ahead start following that. And definitely, I think those regulations will be and those guidelines will be matured as we move along, I would say.
Yeah. Okay. Yeah. Gavin, this is regarding as an advocate or the greatest advocate of wind propulsion system. What do you think the policy change is needed to significantly increase? You mentioned about tipping point, somewhere around 100, and then it will just take over. But what policy change you are looking forward to even grow further?
Okay. How long do we have? You said I could speak for another hour.
3 minutes.
Okay. Right. I'll give you my top three then. Well, number one would be great. Would be a mandate for every ship to be wind propelled, but I think I'm sort of moving into fantasy land there. No, I would say the in a sense the bluntest or the easiest way for us to recognize the benefit of wind propulsion is through the delivering the real price of using fossil fuels and alternative fuels. Now, what I mean by that is there are massive direct and indirect subsidies going into fossil fuel development and into alternative fuel development. There's externalities, for example, and the one I will focus on very much is the carbon price, but there are externalities around health costs. Remember, maritime fuel is not taxed at all. So, in fact, fossil fuel probably is about 3 times more expensive than the market price indicates. But we externalize everything. So everybody pays for it in different ways. So to help equalize that would be the carbon price to be the most ambitious we can possibly do. Now, the Pacific Islands have a proposal for $150 per ton CO2 price. Trafigura actually recommended a $250 per ton of CO2 price. But the key thing here is, the price of CO2 and the cost of fuel. If it's the same for everyone, that is not such a massive problem, because we're all in the market, therefore making a step up. But equally, we would advocate for that to be a circular tax. So as much as possible, that money coming back into the industry, or subsidizing countries who have challenges like SIDS and LDCs, they are subsidized to actually be able to buy these installations, do the training, etc. That creates a double whammy, a double hit, that we get those. But other things, I would say one other policy change would be very much creating a wind code, a very standardized approach to all of these issues, so that clarifies everything for the whole market. But the prime one would be that first one. But I've got a bag of about 20 others, if you would like them.
Well, this is fine. This is good. I hope this comes sooner than later. Ashila, over to you. So,
Yeah. So I think we have already exceeded the time, but it was great. There are a lot of questions actually still there, but unfortunately, we don't have enough time for answering all of them. But thanks to all our keynote speakers for your insightful answers. And I'm sure the five of you could sit here for another hour and speak on the same topic, and you guys won't be bored on it. So let me wrap up the section and thank you. And thank you to our audience for your participation. And if you have any further questions, you can comment below. We will make sure we'll hit some answers for you there. And we will be sharing the recording shortly on the YouTube channel as well. So you can go there and check out the video if you want. So have a great day and thank you. Thank you, everyone. Bye.
Thanks.
Thank you.
Thanks.
Thank you. Bye
Thanks. Thank
bye.
you. Bye.
take care.
Thank you.